Good morning, geometry. Today is Thursday, May 7th, and today we are going to be looking at finding the measures of angles formed by lines that intersect either on a circle or inside of a circle. Here's our first case that we're looking at. So as you can see, these two lines intersect inside of this circle O. These two lines are secant lines because they cut through the circle at 2 points. So what this says is if two secants intersect inside of a circle, the measure of the angle formed is half the sum of the intercepted arc and the intercepted arc of its vertical angle. So let's get an idea of what this actually means. Basically what this is saying is that if we want to find the measure of angle 1, it is equal to its intercepted arc plus the intercepted arc of its vertical angle. So you need to think back, definition of vertical angle means the angle formed, the non-adjacent angle formed by the intersecting lines, and its intercepted arc. So you can also think of this as an average because we're adding them up and dividing by 2. We're going to add up these two arcs, the first one and the second one, divided by 2. That'll give us the measure of angle 1. The other cases that we could run into, one is if a secant and a tangent intersect at the point of tangency. So notice that this line, the green one, is a secant line because it cuts through circle Q at 2 points. And this purple line is a tangent line because it only intersects the circle at 1 point. So what we know is if we want to find the measure of each angle formed, it's equal to half the measure of its intercepted arc. So you can kind of almost think of this as an inscribed angle. If we wanted to find the measure of angle XTV, that would be this angle here. So that creates this angle. What we do is take half the measure of arc TUV. Arc TUV is this major arc here cut off by that angle. Similarly, if we want to find the measure of angle YTV, that's this angle here, creating this angle measure, what we need to do is find half the measure of arc TV. So we're just finding half the measure of this arc that it cuts off. Okay, so those are our two. Sorry, I was thinking there was another case. Just those two. Let's do this as an example. Use intersecting chords and secants to find x. So remember, we said the angle measure here, if it's inside the circle, is equal to the measure of its arc and plus the measure of the arc of its vertical angle divided by 2. So what we're going to say is x is equal to 130 plus 84 divided by 2. So let's simplify this. You have to add this numerator first because technically there's a parentheses around this. And remember PEMDAS. So parentheses comes first. We have to add up those numbers first. That gives us 214 divided by 2. Now we can divide. 214 divided by 2 is 107. So x is equal to 107. Okay, this case is a little bit different. If we wanted to find x, normally we would take the average of arc BD and arc AC. However, we don't know either of those arc measures. So what we can do is first label the angle adjacent to it y. If we can find the measure of angle y, this angle y, then notice x and y form a straight line. They're supplementary. They add up to 180. So let's first find y. We know that y would be the average of its arc and the arc measure of its vertical angle. So y is equal to 75 plus 143 divided by 2. That gives us 218 divided by 2. So I know that y is equal to 109. Now, remember, we weren't looking originally for y, but we just found that this angle here is 109. Now, remember what we were planning. X and y together create a straight line. So remember, that means that they must be supplementary. We know x plus y must add up to 180. Since we found that y was equal to 109, now we can solve for x. So x must be 180 minus 109, therefore x is 71. So if you ever run into a case where you don't have the arc measure for the angle you're looking for, nor do you have its arc measure for its vertical angle, possibly check if you could do this same kind of approach. Let's try one more, part C over here. So this time, x is actually on the arc measure. So here's what we need to do this time. We know that this angle measure, 110, would be equal to its arc measure plus the arc measure of its vertical angle divided by 2. Now we need to solve this equation for x. So what we're first going to do is multiply by 2 on both sides. That cancels this out over here. So we're left with 2 times 110, that's 220, equals x plus 97. So what number adds with 97 to give us 220? Well, let's subtract 97 on both sides to find that out. 97 minus 97 is 0. We don't have to write x plus 0. That would be silly. So that gives us 123 for the value of x. Go ahead. There are 3 practice problems below. I'd like you to try those on your own before you look at the answers. Pause the video now. Here are those solutions. So just like before in A, it was just a normal problem. You found the average of its arc measure that it intercepted and its arc measure of its vertical angle. In part B, we had to do a little strategy where we found y first, then we knew x and y were supplementary, so we knew that they have to add up to 180. Finally, for part C, we had that we were missing the arc measure. So we had to set up an equation, 128 equals x plus 154 over 2, and solve from there. So remember, the first step, just like before, was multiply by 2 on both sides. That would cancel on the right side, and then solve just like we did before. Let's do one more example. Example 2. Now we're looking at tangents and secants intersecting. This time we want to find the measure of angle QPR. So let's highlight. Angle QPR is this angle here. It cuts off arc PR. And remember, we said the measure of angle QPR would have to be equal to half the measure of the arc it cuts off, arc PR. Now we know arc PR, its measure is 148 degrees. So we'll plug that in for the measure of arc PR. That leaves us with the measure of angle QPR must be equal to 74. Let's do one more example. This time we're finding the measure of arc DEF. That's this arc here. So, let's see what we're going to do here. First off, all we know is this angle measure here. Angle FDC. However, if we can find the measure of arc FD, remember the measure of a full circle is 360 degrees. So let's find the measure of arc FD first. Now I know the measure of angle FDC is equal to half the measure of arc FD. Remember, the angle is equal to half the arc. So I can plug in 64 for the angle measure since that's labeled in my figure. Whoops. I know the angle measure here. And I know that has to be half the measure of the arc. So just like before, we will multiply by 2 to get from the angle measure to the arc measure. So when we multiply by 2 on both sides of this equation, 1/2 times 2, that cancels out. 64 times 2 gives us 128 for the measure of arc FD. Now, if I know the measure of arc FD is 128, remember we just talked about how the measure of a full circle is 360 degrees. So what we're going to write is another equation. We're going to go up to here because I don't have enough space down at the bottom. But what I'm going to say is that the measure of arc FED, that's a major arc all the way around here, plus the measure of the arc we just found, FD, makes up the whole circle, 360 degrees. So I'll fill in 128 for the measure of arc FD. I'll leave everything else in the equation the same. Now I can solve this for the measure of arc FED. All I need to do is subtract 128 on both sides. 128 minus 128 is 0. So I get that the measure of arc FED is equal to 232. Okay, there are some practice problems below. Go ahead and pause the video and try that on your own. Here are the solutions for those two problems. They're just like the two problems we did. And finally, your homework tonight is on page 746. You have numbers 8, 10, 12, 14, 16. Your reflection question tonight is to tell me what specific questions do you still have about today's goal. Don't just tell me you need more practice. That's not a question. If you don't have any specific questions, what I need you to do is write down a similar problem, make it up, make up your own problem, draw a circle, draw a figure, solve for whatever you want to solve for to answer your made-up problem, and then solve it. There you go. That's all I have for you today. Have a great day. Bye, guys.